Revisiting this same problem, we want to run a hypothesis test to determine if there's enough evidence to prove that a higher percentage of unemployed people have routine medical checkups than do employed people. Went ahead and maintained that population 1 was the employed people, population 2 unemployed people, P1 being the percentage of employed people who have routine medical checkups, P2 being the population percentage of unemployed people who have routine medical checkups. And based on the two samples that were collected, the difference being negative 0.106, seeming to indicate that the unemployed people have a higher percentage of them have routine medical checkups. So I want to run a hypothesis test, and I want to see if there's enough evidence to show that the unemployed people have a higher percentage of routine medical checkups. So setting up a null and alternative hypotheses. I want to show that P1 minus P2. Now, if I'm going to try to show that the unemployed people have a higher percentage, then I'm trying to show that this difference is less than 0. And I will assume that it is not. And go ahead and create my sampling distribution centered at 0. This is a lower tail test, 0.05, negative 1.645 on the lower end. My standard error. Now, again, we're running a hypothesis test, and the center of this is 0, assuming that the population percentages are at least equal, with the possibility that the first population percentage is larger. That's the assumed. So I need to go ahead and pool the sample percentages and come up with a standard error. So I'm going to go down here at the bottom of the screen and work on those formulas. In other words, if I'm on the lower end, assuming that these percentages are equal, I have two estimates of those percentages, so I'm going to average them or pool them. This is a weighted average. So this would be 1,140 times 0.563 plus 1,106 times the 0.669 over the sum 1,140 plus 1,106. Calculating that, I get 0.6152. And my standard error, plugging that in as a pooled percentage, I get 0.6152 times the complement. And then times 1 over 1,140 plus 1 over 1,106. And doing that calculation, I get finally what I'm after, 0.0205. So that becomes my standard error that I need to run the test. So I can move on here. My rejection rule is reject H sub 0 if my test statistic Z is less than negative 1.645. Step 4, my test statistic Z is 0.563 subtract 0.669. Subtract what I'm testing against 0, 0.0205, which I just calculated as my standard error, negative 5.17. So I can conclude reject h sub 0 since negative 5.17 is less than negative 1.645, and say that unemployed people have a higher percentage of routine checkups. Now, the p-value on that is essentially 0. This is a lower-tailed test, so anything less likely than the sample difference that I have is pretty much 0. We already have a test statistic that's an outlier for the sampling distribution that we're assuming from the null hypothesis. So the center of this distribution can't be 0. It's much further to the left. How far to the left I don't know, but there's certainly under probability confidence that the unemployed people do have a higher percentage. So we have a one-tailed, lower-tailed hypothesis test proving that.